Hello, welcome to today's session. Today we will be discussing about artificial intelligence. This is the term everyone must have heard, and today we'll be discussing about artificial intelligence. What exactly is AI? AI refers to the ability of machine to think, where we are enabling machine to think, that is called artificial intelligence. How this differs from traditional programming. In the traditional programming, we explicitly code the instruction for the computer to follow. But here in AI, we will not give instruction to the machine. Rather, we will let the machine think and to work according to the instruction. So, let us discuss about machine learning. So, let's say this is AI, and machine learning is a subset of AI. Now, let's say AI includes, let's say, playing chess, image recognition, and other tasks like assistant, like your Google Assistant, Amazon Alexa, and else. That everything includes in AI. So, a subset of AI that is called machine learning that deals with data and learns from the data and give us some prediction and insight from the data. That is called machine learning. So, artificial intelligence AI is a broader term, and machine learning is a subset and most important part of AI. Now, we will see what is machine learning. Let's say you are given some data. You want to know about some information about this data, or from this data you want to know how this varies, or how this, what information does this data give. So from this data we want to learn pattern, trend. So all these things are done in machine learning. In machine learning, we divide machine learning into few different subsets, like supervised machine learning, unsupervised machine learning, and reinforcement learning. In supervised machine learning, we, the developer, give uh, data to predict. We give goal to the machine, where to reach. In unsupervised learning, the machine finds pattern. Let's say this is your X data and this is your goal. This is what you want to know. So if Y is given this data, that is called supervised machine learning, and you don't know about Y, you want to find what are the intricate patterns in X, that is called unsupervised machine learning. And in reinforcement learning, we basically tell the machine to perform some task, and based on the task we give reward or punishment. Okay, so this is what we will learn later, but now we'll focus on supervised machine learning. In supervised machine learning, the most important and most basic knowledge is linear regression. Then what exactly is linear regression? Let's say you study for some hours, study hours, and based on the study hours, you get some marks. Let's say if you study for 8 hours a day, you get 90%. If you study less, let's say 3 hours a day, that result to 50% of the marks. Okay, so you want to know, if you want to score 95%, how much hours you need to study. This is the problem we want to solve. Okay, to solve this problem, we need to understand how we represent data. This is Cartesian coordinate system. This is x-axis. This is y-axis. In the x-axis, let's say we plot hours, study hours, how much time we give for our studies, and this is the marks we get after studying for this particular hours. Let's say this is 1 hour, 2 hour, 3 hour, and so on. Okay, so as we can see, if you study more and more, you get more and more marks. Let's say this is 50%, this is 70%, and so on. Okay, now what is this? This pattern follows a straight line. So we want to know what is my straight line, that how much I study to get 95% marks. So for that we need to understand this straight line little more deeper. Let's go deeper into the straight line. Before that, I want to talk about independent and dependent variables. Let's say here, this is study hours, your marks. Your marks depends on something, that depends on how much time you study, that depends on how much sleep you get, that depends on how much focused you are. These all are called independent variables because these things are not dependent on any other things. But for the marks, this depends on all these independent variables. If you study more, you can expect to get more marks. If you sleep well, your brain will be activated better, then you can expect more marks. So this is called independent variables, this is called dependent variables. In typical fashion, we plot all the dependent variables here, sorry, independent variables here in the x-axis and dependent variable in the y-axis, and this is the coordinate system. To define a straight line, we use the equation y equals to mx plus c. So what are the terms here? if you want to know, this is your dependent variable, this is your independent variable, this is some constant, and this thing, this is very important, this thing is called slope. If you want to know more about this all three terms, let us go and discuss about this. Let's see. This is your coordinate system, x-axis, y-axis. So if you want to define any straight line here, what you can do, let's say you defined y equals to 0. What will this tell you? This is the straight line, basically the x-axis. If you say y equals to 5, this is also a straight line passing through y equals to 5 point. If you want to bend this straight line, you need to curve this point. So there will be some slope. See, this is higher, this is lower. There will be some slope. This slope is called m in the equation. So how this slope depend? See, this is the slope. Okay. So for x equals to 1, we get some value like y equals to 1. For x equals to 2, we get y equals to, let's say, okay, 2. Y equals to 4. So the more we increase the x, the more the y increases. So I want to demonstrate this in a beautiful software called Desmos. See, here as we can see, if you put y equals to 0, this means this is the straight line that follows the x-axis. So if you want to take this straight line little upwards, we can increase it to y equals to 5. Now see, the straight line that is defined at y equals to 5, that cuts the y-axis at 5 and follows x-axis. So this point, this point, this is the important. This is the constant that y equals to mx plus c I was talking about. This is the constant. So where the plot, your straight line will cut the y-axis is called the intercepting term. This is the constant c. So if you want to bend this line in a slope, so we can add some term like some slope 0.5 multiplied with x. Let's see the slope. This gives the slope, but this is cutting the y-axis at 5. This is the constant c. If we remove the constant, we can see the straight line follows the 0, 0 point. If we get subtract 2, this follows the straight line that cuts the y-axis at 2. If we add some constant like 6, here is x. So what happens when we increase or decrease the slope? Let's see. If we take the slope as 2, as we can see, the line is upright, straight, getting straight. If we decrease the slope, the line gets flatter. See, the more we increase the slope m, the line bends. And the more we change the constant, this defines that where this line will cut our y-axis. Why this is important? Let us now see. Let's say this is the marks and this is study hours, and this is the marks you obtained. Okay, so now you have studied 1 hours, you got 40%. You have studied 2 hours, you got 60%. You have studied 3 hours, you got 75%. Okay, let's just imagine this. Now you want to see, you want to know if you study for 2.5 hours, that you have not know, you don't know. Okay, right now you don't know that what will happen if you study for 2.5 hours a day. From this line we can say that this will result you around 65% of marks. Okay, so we know some points for some values of study hours how much marks you got, and we don't know about some points how much marks you got, like this point or this point. We want to know how much marks will you get if you study for 1.5 hours, or if you study for let's say 2.2 hours. You want to know that. So for that we want to fit these points into a straight line and get the prediction from that line, that if this line is continuous, so whatever point I can take here inside this line, and I can get some corresponding value of marks. This is the point. So how this is a supervised learning? Because we know some marks for some study hours and we want to predict some more. Okay, so how this prediction will help us? This prediction will help us for certain hours how much marks will we get. Now that we have understand the theory, let's code it. If we open a notebook, here as we can see we have study hours and marks obtained. Let's say this is your study hours. If you study for 1 hour, you will get 45. If you study for 2 hours a day, you will get 50. If you study for 2.5 hours a day, you will get 55, and so on. So if we want to explain this, so we have taken pandas. This is the most popular library to handle this tabular data. So we import pandas, and this is the name we give to pandas. Because pandas is a big name, we will call this, excuse me, we will call this as PD. So this is how your data is defined. Study hours gives all the study hours, and obtained marks gives all the marks you have obtained studying for this particular hour. So we convert this data into a pandas data frame. This is basically the table I am talking about. So now I'm displaying the table for your reference. This is the table. Okay, so here this is not as much as understandable that how the data is varying. So we want to plot it. So to plot it, we want matplotlib.pyplot. This is the most popular plotting library used in Python. So we call this as PLT. This is the short form like your name the alias PLT. Okay, so we plot a figure. This is the size of the figure. The type of the plot is scatter plot. Scatter plot basically means all the points will be scattered in the workbook. This is the scatter plot. Scatter plot, in the x-axis we want study hours, in the y-axis we want obtained marks. Okay, now in the x label we set this label study hours. In the y label we set this label obtained marks. In the command plt.title we give this plot a title study hours versus obtained marks, and we define the limit from 0 to 100 for our marks, that we can the minimum marks is 0 and the maximum is 100. Okay, we want the grids to be visible and all the legends to be shown. This is the plot. So we can get a brief idea that our data is slightly linear, or okay, linear with some deviation from the line. Anyway, we want to plot, we want to fit a linear line to get what the value for, let's say, 4.9 hours a day. How much marks will we get? So to plot this, to make this fitting, we want linear regression. Linear regression basically does this, it understands the data and tries to predict y equals to mx plus c. Okay, so it tries to understand that what m value and c value will fit our data perfectly. So to use linear regression, we import linear regression from the popular library called scikit-learn. sklearn, that is the short form of scikit-learn. And from linear model we import linear regression. And NumPy is the most popular number manipulation library for Python. So here our x or independent variable is study hours. So we defined x equals to our data frame that we have already defined as df, this table, and take the column study hours. And y, we defined it as obtained marks, that is our dependent variable. So our data is ready. Now it's the time to call the model. So this is the linear regression model we will be using for this task. So we define a model variable and give it the linear regression function. So this model has fit function. This function fits the x or independent variables and dependent variables y, and tries to predict m the slope and c the intersection point. So after running this model.fit, our model tries to understand how to fit a straight line for this problem. After fitting this, we go for prediction. So we want our model to predict how well it performed. After prediction, we want to plot the straight line that we wanted to fit. So for that, we again do scatter plot. This time we will be using a straight line. So we take we plot its obtained marks and study hours. Then we try to predict this from our model. So this is the label we give this plotting that I have already discussed, that x label, y label, and this legend. This is fixed by x label, y label, and legends. So to plot this straight line, we use study hours and our prediction that we have done previously. Wipe red, this variable, this wipe red, and the color is red. So this is the regression line we are getting from fitting the linear regression model in our data. So as we can see, this model perfectly fits our data. Then we can say that for 4.2 hours we will get some value around this line. So what are the M and C, the slope and intersecting point that our model got? So the intercepting point that our model got is 39.09. So if you study 0 hours, let's say, you can expect that you will at least get 40% based on your previous knowledge. And if you study more, the more you study, the more marks you get. The slope of your study hours and obtained marks is 7.24, that is the M value, and this is the intercepting term C. Now let's predict some uh, values that are not present in the data. So let's say you want to predict what happens if you study for 5 hours a day. If you run this, sorry, let's rerun all this. So this is the table, this is the plot, this is how we do linear regression, this is the fitting model, and how now we will be doing some prediction. So say if you study for 5 hours a day, you can expect to have 75% marks. If you study, let's say, that is not in the model, 6.6 hours a day, we don't have any data based on 6.6 hours a day, but we can predict it based on our this state line. So if we say that we have studied for 6.6 hours a day, how much marks will we get? That is 86.89%. So this is how you done a linear regression model. So where this can be used, this can be used in many different places. Let's say you have a house. This is the house you have. This has some bedroom, some kitchen, some living room. This is the total square feet area, and it has some value, let's say 15,000 rupees. If you want to know that what the cost will be for a 3-bedroom apartment with a kitchen and this much floor space, so you will have a database that will include your independent variables like your square feet area, number of bedrooms, number of kitchen, number of bathrooms, and so on. And you will predict the dependent variable, that is the price of the house. So you may not know what will happen if you have 4 bedroom, 2 kitchen and 1 bathroom. So this data is not known previously, but from our knowledge of this, we can predict what will be the cost for this house. This is the typical use for linear regression. Hope you have understood how linear regression is done, what are the predicting use, what are the purpose of linear regression, getting relation, getting trend, and etc. So, for a quick rewind, I want to say that what we have learned, that AI is everything, including your chessbot, image recognition systems, robotics, your assistants, and so on. So many things are there in AI, and a subset of AI is called ML, machine learning. This machine learning includes learning from data. Okay, this machine learning includes from learning from data. This machine learning has three important divisions: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning, where we know the independent variables and the dependent variables, and we want some relation from from independent to dependent variables. That is called supervised learning. In unsupervised learning, we know only the data. Let's say all independent variables. We want to see some pattern how this data is distributed. Where this is useful? This is useful for segmenting customers based on their purchasing history, segmenting news based on their topics, and so on. In reinforcement learning, this is advanced topic of machine learning where we give some credit or punishment for good or bad. So the model tries to do of its own, and we want to reward it with some good result and punish it with some value so that it can learn what to do, what not to do. This is called reinforcement learning. I hope you have enjoyed today's session. Thanks for watching. Bye.